Hello, this is Ms. Prather, and today we are going to be working in our Calculator Inactive booklet, and this problem is projectile motion. Projectile motion is quadratic, so just always keep in mind when you're working with projectile motion, you're working with quadratic formulas. Okay, so I'm going to go ahead and begin the problem. And you know, if you've seen any of my other videos, as I read, I like to highlight. An object launched directly upward at 64 feet per second from a platform 80 feet high. What will the object's maximum height be? I'm going to highlight this because this is my question. When will it attain this height? When will the object hit the ground? Go back and make sure I have this highlighted nice and low. I'm also going to actually go back this time and underline my keywords in my question. So it said, what will be the object's maximum height? When will it attain this height? When will the object hit the ground? Now that I've underlined the keywords, there are also several other keywords in this problem that are hidden. What will be the object's maximum height? What will let me know, as well as maximum height, that I want feet. How high will this be? That's what it's asking me. When will it attain this height? When I'm talking about when, I'm talking about time. And when will it hit the ground? Again, here's that word when again, talking about time. Okay, so in order to begin, I'm going to go back and I'm going to read the first question again, and I'm going to figure out what do I need to know. So it says, what will be the object's maximum height? I know already what projectile motion looks like. So I'm going to go ahead and draw what projectile motion will look like in this problem. So this would be as if this was my X and my Y. An object is launched upward. It's going up, and then it's going to come down. This is the point that I want to find, the maximum height. Okay? To find that maximum height, because it's a point, I know there's an X, and I know there's a Y. To find this X right here, we call that X the vertex. And the formula to find the vertex, the X and the Y, to find that X, you want that to be your axis of symmetry. And the formula for axis of symmetry, X equals negative B all over 2A. Okay, so you're like, Miss Prather, where did you get this negative B and where did you get this A from? Well, if you think back to the very beginning of quadratics, we know that the first number is A, the second number is B, and the third number is C. So if I want to find the X axis of symmetry, or the X in my vertex, which is this top point right here, I need to know negative B. Negative B, or you would say the opposite of B, so if your B was already negative, it would be positive. So X equals opposite of B. If that's positive 64, I have negative 64, all over 2 times whatever my A is. In this case, my A is negative 16. Go ahead and simplify that. Negative 64 all over negative 32. Negative 64 divided by negative 32 is positive 2. My X is positive 2. That would be my axis, where my axis of symmetry is at. And so what I'm going to do to find this, to find the vertex, the actual point, I'm going to take this X, or in this case the problem has T squared, and T, most problems may have X squared and X, it doesn't matter. I'm going to take that and I'm going to substitute it back into my problem, because that is going to tell me what my height is. So I'm going to rewrite the problem. And as I rewrite the problem, instead of putting T in here, I'm going to put the 2 there. Okay, and again, do not get confused. I chose to use X and Y. As you see, the problem does have T and has H. Your EOC may do the same thing, so do not get confused by the variables. In this case, I do have X being the same as T, so that's why I put the 2 there. Okay, so I'm going to go ahead and simplify this. Negative 16 times 4 plus 64 times 2. And if you're not sure about that math, you can do it off to the side. 64 times 2, you have 8, 128, plus 80. Now we're going to simplify negative 16 and 4. So I have that again off to the side. That's 24, 6, and bring down that negative. So I have H of T equals negative 64 plus. I'm going to go ahead and add these together. To add this together, I have 128 plus 80. That's 208. Now I know I need to finish simplifying because this is a negative and my sign of the large number is positive. I know my answer here is going to be positive, and so all I have to do is just subtract. So I have 208 minus 64. That's 4, cancel out. 1, 10 minus 6 is 4. Bring down that 1, 144. So in this case, my Y, or my H of T, is 144. So I'm going to put both of these together. I have the X is 2, and my H of T is 144. And I'm going to highlight that. Because what this lets me know is that this is my axis of symmetry. This is also at 2, 144, my maximum point. So I go back to the first question. What will be the object's maximum height? If you can remember back into the lessons, we said X will always be time and Y will always be height. So if it says what will be the object's maximum height, let me take this and move it over just a little bit so you can see. The height, which we said would be your Y, is 144. So to answer the first question, what will be the object's maximum height, I'm going to put right here star, max height is 144 what? And then we know we're talking about feet. I'm going to put 144 feet high. When will it obtain this height? This is when we said when was time. We go back to our vertex, that point. X, we said down here was time, so I know my X is 2. We will say it will attain the maximum height, and I'm going to abbreviate maximum, in 2 seconds. So what that's saying is after 2 seconds of the ball being thrown directly in the air, this is when it's going to reach its maximum height before it starts to fall back down. So finally we have the final question. When will the object hit the ground? So this is where the object started. Then we want to find this little point right here. When will it hit the ground? Well, we know that if we were to completely remove this and not think of this as being projectile motion, we were to think of this now back as a quadratic formula, a quadratic function, a quadratic graph. We know that the points along the x-axis, those are the roots. And we can find the roots by factoring out the actual formula. So that is what I'm going to do, and I'm going to move the paper down a little bit so you can see. What I'm going to do, I'm going to rewrite the problem. So H T equals negative 16t squared plus 64t plus 80. Go ahead and move that back down. Okay, so now that we have this problem rewritten, to factor this out, You could either play the X games, you could make a T-chart, you could do whatever. But before you start to factor, go ahead and pull out that greatest common factor. And in the case of negative 16, 64, and 80, the greatest common factor is 16. However, because I have a negative 16, I'm going to pull out the negative with it. So that leaves me with a positive t squared. Now this is where it gets tricky. Because I put out the negative, if I were to leave this as a positive, I would end up with negative times a positive and get negative 64t. That's not what I started with. I started with a positive 64t. So this sign changes to a negative, because negative times negative is a positive, and it's the same thing with this one. If I left this as a positive, I would end up with negative 80. So, and I want positive 80, so negative times a negative is a positive. Okay, so now as I'm looking at this, we have one error. And the reason I did this error is because I want us to think and to pay attention with as we factor. We pulled out this negative 16t, or negative 16, excuse me. But the one thing and the most common error on this, and the reason why I pointed it out in our video, is as you put out this negative 16, you also have to pull out a 16 here and a 16 here. Be careful as not to do this on a test or on a class assignment or in an independent practice. What you really want to do, and hopefully now that you see what it looks like, what you really want to do is you want to pull out that negative 16, leave the t squared. How many times can 16 go into 64? That is 4 times, so it's actually negative 4t. And how many times can 16 go into 80? It's actually 5 times, so it's actually negative 5. So do not, this is a no-no. And hopefully now that you can see the no-no, you will now remember to do it the right way, or this video will come back in mind and you remember to do it the right way. Okay? So now what we're going to do is we're going to factor this out. You set negative 16 equal to 0, and that can't happen, because that's not true. So then I have t squared minus 4t minus 5. Okay? So this is where we start to play the X games. What you want is A times C. So that's 1 times negative 5, which is negative 5. And then whatever your B is, negative 4. So what you want is two numbers that will multiply together give you negative 5, but when you add them give you negative 4. And so those two numbers that come to mind for me is negative 5 and 1. Because negative 5 times 1 is negative 5, but negative 5 plus 1 is negative 4. These are my two factors. I can quick factor because my A is 1. And what I mean by quick factor is that I can easily say x minus 5 and x plus 1. That's quick factoring. And what I have to do now is I have to set both of these equal to 0 and solve for x. X minus 5 is 0. X plus 1 is 0. For the first one, I'm going to add 5 to both sides. X equals 5. And for the second one, I'm going to subtract the 1. X equals negative 1. Now, only one of these can be my correct answer. I have x equals 5 and x equals negative 1. Now I'm going to go back, scroll back up to my drawing. We want where the ball falls. Okay? Where you fall, which is x, remember, is still your time. When we think about time, we think about time being positive. You can never have negative time. You can't, in a way, say go back in time. So when you think about time being positive, and you look back down here, there's only one of these that has the positive answer, and that is x equals 5. As we said, x is time, and in this case, the time we're talking about is seconds. So when we read the question, when will the object hit the ground? We can now write the object will hit the ground in 5 seconds. And as you see, that's what I have right there. Thank you, and I hope this video was helpful. Also, in this video, note that I intentionally put the error so that way, hopefully, we can catch ourselves in the future when we go to do these problems, that we are not just pulling out the 16 or whatever the GCF is for the first number and forgetting to factor out the GCF for the last 2 numbers. Let's make sure we do it correctly so we can have the correct answer every single time.